would like to explain about the logic gates, basic logic gates in any digital equipment, digital electronics, we may call, and digital equipment. So we know that the digital equipment is working on the binary values, that is 0 and 1. Here 0 and 1 not it mean as the numbers. This is the voltage. So what are the basic things we are going to be use to design any circuit? These are the basic electronic elements. Generally, there are three basic electronic elements. First is the AND gate. The second one is the OR gate. The third one is the NOT gate. By combining these three gates, we are going to be form the some other NAND, NOR, exclusive or XNOR gates. By using all these gates, we are going to be form the circuits. So generally, we are representing the symbol of the AND gate like that. Suppose there are the two inputs, and with a big letter like D, and this is the output Y. Suppose let us consider this is the A and this is the B are input. The Y, the output is the function of A dot B. We are going to write like that. And we are also representing the OR gate like that actually. So again we are going to be consider A and B are the inputs and Y is the output. The Y is the function of A or B. Generally, we are going to be representing. The third one, we know that we are going to be representing the NOT gate is like that. It has only one input and one output. Suppose the A is the input, Y, the output Y is the A bar. So, these are the general symbols actually we have to represent the logical gates. So these are the black diagrams, or simply we are going to be call it as a block diagrams. But there is just we are going to be remember or by heart the things how these are at looking. But what is the logic or what is the logic circuit behind it and how they are going to be working? I will explain one by one. Let us consider first we are going to be consider the AND gate. So we are going to be write the AND gate has the two inputs. So the AND gate is like that. The AND gate is like that. It has the two inputs. One input is A and one more input is B and output is Y and Y is the function of A dot B. And generally we write the truth table A, B and Y. Suppose we are given the values to A, B and Y. Suppose this is the 0 and this is the 0. Any one of the 0, 0 into something is 0. So the output is 0. This is 0 and this is 1. Again, we know that Y equal to A dot B. 0 into something is 0. And this is 1 and this is 0. Again, this is 1, this is 0. 0 into something is again 0. And we are going to write it as actually, so 1, 1. So when both are the 1, 1, 1 into 1, 1. Generally, we are going to be representing the electron. False and false, false, generally false and false equal to false. And false and true, this is also be false. And generally true and false, we are going to be representing this is also false. And true, suppose true, sorry, true and true, this is the true, we generally representing. But how the circuit is actually, so let us consider, right? I'm going to be take the circuit here. There are the two switches. Sorry, okay. There are two. Please, I'm going to be take this one. This is the here I'm going to write. This is the one switch. We are going to be call it as A, and another switch we are going to be call it as B. and I am going to be connecting this one to the battery. This is the positive and this is the negative. And let us consider, and I am going here I am going to be attaching a resistance or simply the bulb. So suppose I am close this one. So this is open means this is the zero. This is the zero. These are open. That is the current is not going to be flow here and here. Actually, zero and zero. This is the zero, the value. The bulb is off. Right. Again, suppose let us consider I am going to be on this one even that is this is closed that now this closed means the circuit is closed, this is on, that is 0 and 1 even the circuit is open, the power is not supply in this side, so again the bulb is in the off condition. Now suppose now this time this is closed and I am going to be consider, right, I am going to write one more time, this is like that, this is open, so this is closed, but this is open here. So this is open here. There is no circuit. So again, this is the zero. So 1 and 0, the current not passed, again 0. So both are closed. The both circuits are closed. The current is passed from positive to negative. The circuit is closed and the bulb is on. So the basic logic circuit for the AND gate is this one. This is A and this is B, and this is the, let us consider, this is the battery of this positive and this negative, and I am going to be attaching some bulb is here. This is the basic circuit. And again in the same way we come to the OR gate. Let us consider the OR gate is also be like that. The OR gate is also be like that. There are the two inputs A, B, and Y is the function of A plus B or A or B. Generally, we are going to call A or B. Now we are going to take Y, this one it is A or B. Sometimes we are going to write like that. Nothing to be worried. Suppose 0, 0, 0 plus something, that may be something 0 plus 0, that is the 0, and 0 and 1, 0 plus 1, let us consider that is 1, and 1 plus 0 again, that is 1 or 0, that is also be 1, 1 and 1, this is also be 1. So any one input is high or any one input is true, that is the true. Generally we are going to write it as false or false, that equal to false, and false or true, that equal to true, true or false, that equal to true, true or true, that equal to true. Now we can analyze how the circuit for the OR gate is. I'm going to write like that. Please listen carefully. Let us consider this is A and the same, and this is B, right? This is A and this is B. Here I am going to be attaching one battery, and here I am going to be attaching one bulb. Now the both A and B are open. That means this is 0 and this is 0. The bulb is not working, not lighting. This is 0. Suppose now I am going to be close this one like that. Even this one in this side actually, right? In the in this side the it is turned and this is closed actual, right? So this is open, so this the light is, I'm going to write something, right? The light is on, so the closed and the light is on. Again 1 and 1, the both are closed, this is also be on, and any one is off, this is. The final one is the NOT gate, that is very important. Suppose we are going to write the NOT gate is like that. Suppose we are going to be given 1, the output is 0, we are going to 0, the output is 1. How the circuit will be like that? Let us consider. So the circuit is like that. Let us consider this is the battery and this is the switch. And again, I'm going to write the bulb is here. Suppose now, suppose we are going to be supply the power, right? That means on. Even the switch is off. Actually, that means here we are going to be given 0, but the switch is off. The circuit in this way is that the current is supply and light is glow, that is on. Suppose we are going to be close this switch. Once again, I am going to be draw the same. Sorry, I'm going to be draw like that. Suppose, right? Now here this one. So again, we are going to be send the value, send the current. So the, the opposite of the this resistance of the bulb, a closed one more closed circuit is there. Actually, the electricity supply in this way. The electricity not go in this direction, only supply in this way. Suppose that means we are going to be close the switch on, the bulb is off. So this is the basic circuit of the uh, basic circuit basic circuit of the NOT gate. So, right, these are the basic things to any digital components or the digital electronics. I hope you can understand. Thank you.